21. Now, if you look at the first question, it's the idea of reverse Laplace transformation. So the first question, A, the question was, what if you have a function in terms of Laplace and it was 4 over s, 6 over s squared, and 1 over s plus 8. So this is already in Laplace transformation. Now what if you wanted to take it back to the original? So you need to do Laplace inverse for this. So for 4s, the 6 over s squared and the s plus 8. To do the Laplace transformation, when sigma is added, you can just say, I'm going to do Laplace transformation for the first one, plus Laplace transformation for the second one, plus Laplace transformation for the last one. Now remember this sheet that I sent you? Now you're looking at the right column. This looks like the first one. The first one states it's 1 when the function is 1, when f of t is 1, the transformation 1 over s. This is 4 over s, but 4 is constant, so we can say that originally it was 4 constant times 1. For this one, we use rule number 2. Rule says it's t to the n. When it's t to the n, it's basically s over n plus 1 and n factorial. So you see it's s squared here. So when it's s, was it squared or, let me just, 5. This one is to the power 5, sorry. So when s in the bottom to the power 5, that means that n was 4. So now I know it's 2n to the 4. There is a constant 6. But according to the rule, you need to have the same n factorial on top. We don't have n factorial on top, and when we reverse, then you divide by n factorial. You can look at it this way too. I mean, compare this to this. So you see it in the bottom, n plus 1 equals 5, then n is 4. You need to have n factorial here, but there is no n factorial. You have only 6. So you're going to divide it by n. You divide this by n factorial since we don't have it. And since n is 4, so you're dividing by 4 factorial. The last one, this one here, the rule we use for this one would be rule e to the at equals 1s minus a. You already have it in this form. So there is the 1 but minus, so we put a minus. There is s, so I know it's e to the t. All I need to know is what is a. According to this, minus a is 8, so a is minus 8. So this here was the original function. You can simplify this by saying, well, 4 times 1 is 4, 6 over 4 factorial would be 1 over 4, and this one you can't really simplify anymore. This would be the answer for the first question. All the questions in this assignment are Laplace inverse. So if you consider question B, f of s equals s over s minus 1, s minus 2. Now, in the way you have it now, there is no way, in the way you have it now, there is no way you can do it. The only thing you could do, because if you look at the rules, there is nothing that matches this. We can do the idea of partial fractions. And you took that in calculus 2. So you have s over s minus 1, s minus 2. Now if you remember, when you have this to the power 1 and the outside to the power 1, it takes a letter. So a over s minus 1 and b over s minus 2. And if you remember how we did this, you would find a common denominator here. So a needs s minus 2 and b needs s minus 1, and that should equal whatever the top hand. So a needs s minus 2, b needs s minus 1, and that should match whatever the top here. Now the idea is to see if we can figure out what the constants are, what a is, what b is. There are two methods: comparing coefficients and guessing numbers. I'll do it both ways, and later you'll see, you can do it by whatever way you like. If you do it by guessing, you can figure out a number that cancels stuff, so I can say s equals 2, because that will cancel this. So here we have 2. 2 cancels this. We have 2 minus 1, 1, b, so b is 2. I can plug 1, so on the left-hand side I have 1. 1 cancels the b, gives me minus a, so a is minus 1. This is the idea of guessing. The idea of comparing coefficients, you would say here we have s. I take the a inside, would be as minus 2a. The b inside, bs minus b. Now the s here has a coefficient 1. The s here has a and b. There is no number by itself, so we say 0. And the number that's by itself here is minus 2a and minus b. So now mathematically you need to think of a way you can cancel either the a or the b. What we can do is we can add both equations. 1 and 0 is 1. A and minus 2a gives you minus a. B minus b, 0. So minus a is 1, a is minus 1. Now once you know that a is minus 1, that means b So you know a plus b equals 1. If this is minus 1, then b is 1 plus 1, 2. So now we know what a is and what b is. I put it back in this one. So my function now is a, which is minus 1, over s minus 1, and b is 2 over s minus 2. Now, if you look at the rules that you have, look at the right-hand side, both of them match rule EAT. So I'm going to use EAT 1 over s minus a. If you compare it to this one, there is a minus 1 constant, and the value of a is 1. So it's e to the 1t. If you look at this one, the constant is 2, and you compare this to this, so a is 2. So e is 2t. So this is the function, and this is the Laplace transformation. Good? So we're going to do the next question. Question C, you have a function f of s, and it's s plus 3 over s squared 2s plus 5. Now, this one is a little bit tricky because first, you suppose to factor this. So if you try and factor this, two numbers multiplied to 5 add to 2, you'll see, well, it's kind of hard. So this one, you won't be able to factor, then you think, let's try quadratic. Negative b plus or minus b squared 4ac 2a. Minus b, so minus 2. B squared, that's 4. 4 times a, which is 1, and c, which is 5. All of this over 2 of a, were 2. You do this in the calculator, it gives you negative 16. And you know here, the square root of negative 16, you get into imaginary stuff. And in Laplace, we don't allow imaginary stuff. So at this point, you can't factor, and it doesn't give you a real answer in the quadratic. When this doesn't work and this doesn't work, you need to do what's called completing the square. So to complete the square for this, you have s plus 3. Now for the bottom one, we take s first, and we half of this number. The half of 2 is 1. And then you say squared. So you take s, a single s, and half of this number, which is 1, and you square. But 1 squared gives you 1. There is a 5 here. So the 1, you need to add 4 to complete the square. So you have this number 1, 1 squared is 1, but this is 5, so you add 4. So at this point, we know that this is the complete the square, and we're supposed to be able to do it after completing the square. So I'll write it down again. Now, if you look at the rule, so this is the question. If you look at the rules, you'll see that there is no rule for this. But if you look at the sine and cosine, they're kind of similar to this, but only when it's s squared. This is s plus 1. The plus 1 means that there was shifting. And shifting means that we need to use this rule, EAT FT. So when you do the Laplace transformation for this, now watch carefully. I need to get rid of the shifting first. To get rid of the shifting, all I need to do is use this rule with A being the amount that we need to shift for. So it's 1, so we say it's negative, we need to bring it back 1, so E is to the minus 1. So that's the idea of shifting. So this is to get rid of the shift. The plus, so we go back 1, so it becomes A to the minus t. So you put this outside, you got rid of the 1, so now it's s squared plus 4, and you get rid of 1 here, and that's s plus 2. So you have e to the minus t, Laplace transformation. I can divide this into 2 fractions. I can take s over s squared plus 4 and 2 over s squared plus 4. Now, if I look at my rules, there is a rule for this, and that they tell you it's cosine kt, when that's the function, Laplace transformation for this is you put the s on top and an s squared and k squared. So here we have s squared, we have s, k squared is 4, so k is 2, so this was originally cosine 2t. So the inverse of this was cosine. Remember, there is an e minus t in front of it. Now let's look at this one. So the rule says when it's sine of kt, you gotta have s squared plus k squared and the value of k. Looks like this. K is 2, so 2 squared, and that's a 2, so 2 squared and 2k is 2, so it would be sine of 2t. This is here the original function or the Laplace transformation for the actual question. Okay? Now, the last question in your homework, it's not hard, but it required a little bit of work. So, the question was, your function is f of s, and it's 7s squared 23s plus 30, and in the bottom you have s minus 2 s squared 2s plus 5. Another one that requires partial fraction, so we're going to do partial fraction for this. In the first bracket, since this is 1 and it's 1, so you take one letter. This is squared, so you give it 2 letter in this form. bs plus c over s squared 2s plus 5. For the first one, you need to multiply it by s squared 2s plus 5. And this one, the bs plus c, you need to multiply it by s minus 2. So a multiplied by the bottom, and this multiplied by the bottom, and that should match the original. If you look at the answer I did, in the answer I compared coefficients to find the value of a, b, and c. I ended up with a being 8, b was -1, and c was 5. And I did it by comparing coefficients. You can look at the way I did it by comparing coefficients. But now I want to do it by guessing numbers. You don't have a lot of options, so I'm going to guess or try S2. Because 2 will cancel this, I can figure out A. And remember, A is supposed to be 8. 2 squared is 4. 4 times 7 is 28. 23 times 2 is 46 plus 30. A, S2 squared is 4. 2 times 2 is 4 plus 5. And 2 cancels this. This plus 76 plus this 104. And this is 13a. So a would be 104 over 13. And if you take the calculator, 104 over 13 is 8. So now I know a is 8. I can replace it by 8. So a is 8 now. To figure out, I'm going to try and guess another number, 0. 0 here gives me 30. A is 8. 0 here gives me 5. 0 cancels the b. And 0 here gives me minus 2. So now I have 30. 8 times 5 is 40. And that's minus 2c. Bring the 40 over. Minus 10 equals minus 2c. So c would be 5, which is minus 10 over minus 2. So now at this point, I have the value of a and b, but I can't really, there are no other numbers that cancel anything. I can try any easy number. So I'm going to try 1. On the left-hand side, when I try 1, it gives me 7 plus 23 plus 30. I know a is 8. 1 gives me 1 plus 2 plus 5. 1b, c is 5, and 1 minus 2. The number here is 60. This is 8 times 8, 64. This is minus 1 times b, minus b, and minus 1 times 5, minus 5. 64 minus 5 is 61. You bring it over. 59, sorry. That's 1. That means b is minus 1. And if you look at the answer, that's the same answer we got when we did it comparing coefficients. So now after doing this, my function becomes a over s minus 2 minus s plus c, which is 5, and in the bottom we go s squared 2s plus 5. Now, to do the Laplace transformation for this, and for this, I can take the negative outside, then that makes it s and minus 5, because if you take it inside, it becomes minus s plus 5. And the bottom is still this. Now, if you look at the rules, this rule is the E rule. And the E rule states that if you have e to the at, it's 1 over s minus a. So now I know that I'm going to use this rule, but the constant is 8, and the value of e is 2, so e to the 2t. So this is the answer for the first one. And there's a minus. Now, if you remember, we solved this question at the bottom. We saw the bottom in the previous question, and I told you you're supposed to try factoring. If it doesn't work, apply quadratic, maybe it helps you. If not, complete the square. So we came to the conclusion that we have to complete the square. So we're going to do Laplace transformation for a negative, I took it outside, for s minus 5. And completing the square, if you remember, it was s plus 1 squared plus 4. Now right away, you notice that there is a shift. So we need to get rid of the shift. So we have 8e to the 2t. Getting rid of the shift, you're bringing everything back 1. So that becomes e to the minus t. So I took care of the shift. Now we're left with the following. Taking 1 from this is s squared plus 4. Taking 1 from this is s minus 6. So this is e to the 2t. This is e to the minus t. Now, it's Laplace transformation for s over this and minus 6 over this. Now, s over s squared plus 4, that would be cosine. That matches cosine, so now I know it's cosine of 2t. Now, this one looks like the sine, where k is 2. Remember, k would be this, and a number squared gives you 4. So there's a minus here. Now watch, I'm going to leave a space. It's sine of 2t, but I don't have a 2 here. I have a 6. So you think of what's that number that if we multiply by 2 gives you a 6? 3. Or you just divide 6 by 2, 3. So this would be Laplace transformation for the last question, which maybe was the hardest of all of them, but basically it involved partial fraction, so you need to be good at that, and the shifting also. And this last trick where number's supposed to be 2, you have 6, so you multiply by 3. So that's another. So if the number was 20, supposed to be 2, so you need to multiply by 10 to make it 20. So this is it for this assignment. I'll see you in the weekend, maybe Sunday, to go over the new test. Now, for now, try and review everything we did. Don't leave it to the last minute. And on Saturday, things will hopefully be easy, or Sunday. Bye now.